Okay, we'll get started soon, okay? Any questions so far? Is all homework okay or too hard or too easy? Nick, how are you? Any comments?
I think it was good so far.
Okay, it'll be getting harder, okay? It'll get harder.
Okay.
But the whole purpose is like want everybody to be familiar with the Python numerical package, okay? And that's pretty important, especially if you want to work on the AI or machine learning jobs, okay? That's very important. And that's it. We'll get started, okay? It's noontime already, so let's get started. Okay. If there's no question, what can we discuss? Let's see. Because all of the lecture, I told you guys that you can see the video actually in every week, okay? Every week we do have the pre-recorded video, and that's the lecture we recorded in the year 2020. Okay, so every week you should start it with the lecture over here, and I'm expecting people to ask questions so we can go deeper or go some topic that help you to work on the homework or something. Okay, so here I will not repeat the content of these different videos. Let's actually try to focus on something related to the homework or something that may be done in this week 2. Okay, so week 2's main topic would be on the transformation. Okay, week 2's main topic will be in the kinematic, and it will be basically primarily on the transformation. So we have some extra video that's external video. Okay, it's not by me, but actually is for the linear transformation. Okay, so here we do have some topic about the transformation. So why transformation is important and why linear transformation is very important is it is related to our robotics. Okay, so we do have 2 people. Let me see. Okay, so let me ask. Your name is Jayavadahan, right? Am I correct? Hello? Is that first name or last name? Okay. If it's not,
sir, I'm Jay.
Okay. Let me just call you Jay. Okay.
Yes, sir.
Yeah. If it is not appropriate for you to talk, somebody actually in the bar or somewhere, so it's okay because we are in the new time. So you just text me in the chat. Okay, I will know it. Okay, don't worry. So basically, what is transformation? Hi, Jay. Do you know? We want to talk about the fundamental things. What really is transformation? In your own word, okay? And actually, one thing I would like to discuss is that we do have a discussion, right? And I do post some topic for people to talk about it, right? To discuss, okay? Okay, to discuss it. And you do not need to copy from some website and quote some source. The purpose is not to quote people's words, right? The purpose is just use your own word to discuss. So basically, there are some articles you can read, okay? And I put those articles there just because that I want you to read it and or study it, and then you use your own word to actually talk about it. Okay, that's the main purpose. The purpose really is not wanting you to copy from somewhere and pass it over there, and then what's the meaning of doing this? There's no meaning, right? You just search it for Google and you will find the answer. So that's not the key idea. Why we want you to study in that way. The key idea that we want you to study in this way is that, okay, every week we want you to have discussion, but we do not have a topic. So I posted some topic over there. So if you like to discuss the topic, you can join, you can talk about it, but please in your own words. Hello, how are you? Please in your own words, okay? In your own words. We appreciate, even it's just one line, it's okay. We do not need you to quote the whole article, okay, and what's the purpose for me to read some report from somebody else? That's making no sense. Okay, so key idea is must be your own work, because we want you to read some article, digest, and then get the idea. Yeah, the key point is that we want you to get the idea. What is the real essence of the topic? What is the idea? Okay, and we based on those ideas. Usually, we learn something. We are based on the key idea. If you know about the key idea, then you will be able to know the topic much better. So now go back to the transformation. Okay, go back to the transformation. So what really is a transformation? Okay, this one, if Jay, you don't know, how about, let me see. How about Nick, do you have idea? What is transformation?
Like transformation could be like changing one thing into a different thing.
Oh yeah, that's for sure. Transformer, right? So that's correct. That's actually good description. How about Sudhir? How are you? Hello? Can you talk?
Hello, sir. Fine.
Yeah, can you talk?
Yes, sir.
So what is a transformation in your own word?
Changing from one form
one form to the other form, okay? And mathematically, when we define the transformation, really, okay, sometimes we do have a few different transformation, okay? One is translation. Translation means that point A move to point B, right? So when you have motion, your car move from one location to the other, that's actually its movement. Second, rotation. Okay? Rotation is that you have an object this way, you rotate a certain degree. Okay, that's rotation, right? Third one is what? Third one is you have translation, you have rotation. Third one is scaling. Third one is scaling, scale. Scale means you have an object, now you actually make it bigger, x-wise, how big it is, y-wise, how much you change, right? That's actually transformation. Number four would be the skew. Okay, skew is you don't move, you don't rotate, you don't make bigger, but your body originally is this, but now it's skewed by a certain angle and become this. Okay, so number 3 and number 4, if you have rigid body means that your shape never change. You don't have those kind of transformation. So when we talk about linear transformation, we don't talk about the motion of some object. It's really just the translation and also the rotation. Okay, the scale and skew, no, we do not have the scale and skew. We do not have scale and skew in linear transformation in the rigid body, okay? So when we talk about some motion in robotics, usually we are talking about rigid body. So there's no scaling, there's no tilting. But do you need to learn these things such as skew and the scaling? Yes, sometimes you do need that, okay? Let me give you some idea of when you may need to study that. Okay, so let me bring up my slides in the web design course. Okay, I do teach some web design course. So let's see here, we do have the animation of web page. Okay, so when you do web design, you do game design, okay, you need to have heavy calculation of the metric as well. And it's similar to the robot. So you control your robot arm, you control your machine, you control your car, you control your vehicle. It's similar that when you do projection on the 2D and it become a graphic design. So the transformation is similar. In the web design, we also have the transformation, okay? In web design, we also have transformation. And those transformation may have transformation in 2D or in 3D. Okay, so this is CSS transformation in web design. So your 2D transformation, you do have a rotation, you do have translation, and these two, as I mentioned, is rigid body transformation. So it can be formulated by the linear algebra, right? And then you have a scale, make it shrinking or growing. Okay, scale. So these two are non-rigid body. Okay, these two are non-rigid. But when you study it, you do need this and this. Okay, I'll explain why even rigid body you still need to study scale and skew. Okay, that's actually these are 4 basic transformation, and we do have picture. You can skew, you can scale, you can actually rotate, okay? And all of these need to have the mathematical calculation. So you see, you learn something that related to robotics, but it can be applied to graphic design, applied to web design, applied to game design, okay? Applied to many things, okay? So this is 2D. 2D, you have this different transformation that you can do, okay? I'm not teaching you based on the boundary, okay? I just talk about some topic, and based on a mathematical model with what we can do, okay? Then that's 2D. And after 2D, we do also have the 3D, okay? This whole thing is a whole chapter, so I cannot go over everything for you, but you just need to grab the basic idea, the key idea of the transformation. There are 4 different operations in the transformation. And then we do have a 3D transformation, right? 3D transformation. So 3D transformation, what's that for? You do have a picture, but the picture you want to actually rotate it in 3D so that it's, okay, your front view is like this. And you may have a rotation along a certain, okay, so here your picture is like this. You do have the XYZ axis, right? So that's assume that this is Z axis. You may want to rotate along the Z axis and your picture will become this, right? So this one is a 3D rotation, but it is a 3D rotation, but projection in 2D domain. And there are some maths you need to calculate to make you see it, okay? So in order to calculate that, okay, this math is more complicated than the 2D one, okay? So the different browsers support different rotation, okay? But we do not want to go into the deep detail there. We want to see, what we want to learn is this 3D model. So each 3D, if you learn some art design before, then you will know that each 3D model would have some sort of vantage point, some with one vantage point, some with multiple vantage point. That's actually is a 3D model. Okay, so let me try to actually draw a building. Okay, so basically, if I use a 2 vantage point, especially when I have a tree, and I do have east, right and left 2 vantage point, and I'm trying to sketch in the vantage point like this. Okay. And the vantage point is for me to draw a building. So I can draw a building in this way based on the box, right? So this one would be my, say, 2-story buildings drawing. If I follow the 3D model and the tree is like this, right? Tree is like this. Okay, so that's actually very small. So you draw your 3D buildings graph, okay, or picture on a 2D canvas, right? So you need to have a projection model. So something like that is needed, okay? Something like that is needed. And then we need to have some transformation, some math calculation to do this, okay? So there are some tools you can use on the internet about how to generate a 3D metric, okay? Anyway, the key point is that, okay, what is this transformation related to our robot? Okay, let's go back. Okay, so okay, so now let's go back to our robot. So let's assume that we do have a robot arm, right? Robot arm, and I'm controlling my endpoint. So basically this one can rotate, and then this one can actually extend. to reach something. Okay, so the endpoint location is here, but this one, no matter how you extend it or you rotate it, this we can call it frame 3. Frame 3 actually is coordinate built upon based on the frame 3, and then you need to doing observation based on frame 2, because the frame 2 may do rotation, right? So your endpoint, absolute location of the endpoint would change when your frame 3 has some rotational extension. Will also change when your frame 2 has some actually change your rotation, and then also will change if you have frame 1, this rotor joint has some change or rotation, you will also have some change. Or you will have F0, your base may rotate this way. Okay, so there are 4 transformation, 1, 2, 3, 4, 4 transformation involved in this robot arm control, and it is in a 3D space. So that's why in week 1, we want you to work on the generation of vectors and metrics and something in 3D. Okay, something in 3D. That's the purpose of the warm-up homework in chapter 1, right? And then that's something. And we need to learn those linear algebra in order to model this different transformation. Okay, so those are transformation basically primarily because it's rigid body. Okay, because it's rigid body. So what you would do is actually only number 1, translation. You may have some prismatic joint that actually you have extension. So you may have transformation that actually is translation. Okay, translation. And you may have a rotation. Okay, these two, the first 2 transformation, you will have it. Okay, so that's the 2 kind of the things that we usually do. But because your robot is rigid body, so there's no scaling, no skewing will happen on this system. Okay, but that's happening on a 3D space. Okay, and besides that, this robot have a robot arm. And it may be connected to a robot, and there is a robot sensor. There's an eye, right? So the eye actually look at its workspace, right? And then you will see where there's a package, and you want the robot arm to pick up, right? So you need to know about how far away this endpoint and that picture is. So the picture being taken to the sensor, but remember your picture is 2D picture, right? And then you need to build a 3D space model. So to recover the image from 2D to 3D, again, this one is a 3D modeling. So that's where we talk about the CSS 3D modeling and vantage point. The theory of the vantage point will be applied to. Is that okay so far? Is that okay so far? So to be short, within transformation, the main purpose is to model the robot arm behavior, and also to model your environmental parameter that you observe by your sensor of the robot. Okay, that's the purpose for doing that. Okay, so far okay. Okay, any questions so far? Nick, is that okay?
I don't have any questions yet.
Okay, no question. So if no question, we will continue. Okay, so this is about why we started this transformation. Okay, why we want to study the transformation. So now I try not to repeat whatever you can learn from the video. Okay, but I try to give you the key idea of what things are. So when you watch the video, you will have some concept. Okay, and you know how to ask question also. So right here, let's look at the basic theory behind the transformation. Okay, basic theory behind the transformation. I'll start from pretty simple one. So I'm going to use a different slides that I use for introduction to robots. Actually easier course. Okay, let me see. First one is actually look at the kinematic. Okay, this different video also is can be found in the course. Okay, in your prepo course. Okay, so basically, before we get started, we need to know about some basic term. Kinematic diagram, KD, kinematic diagram. So when I want you to draw the kinematic diagram in some homework, we are talking about this. Okay, these are something related to homework now. Okay, so what is robot model? What is kinematic model? Okay, so you do have a robot and you do work on the architectural model. Is that this is a robot computing model? Okay, and this is okay. I think we showed this several times. So robot arm is itself the manipulator. So robot arm is the manipulator. Okay. Robot arm is the manipulator. So okay, whatever, it can be controlled by cell phone, remote control, PC, mouse, whatever. Okay, kinematic diagram is you try to draw your robot in such a way. Okay, in such a way. So when we make such a scene as a circle, this one is a revolution. So when I want you to actually draw a kinematic diagram, I just need you to draw this, okay? And then there's a link. You use one bar or you use one line, actually I'm fine, okay? So if this one, you draw a kinematic diagram in this way, that's actually acceptable, okay? That's actually acceptable. And here you only use an arrow, that's actually acceptable. So by this, we already know that this is your model for a robot arm. Okay, so this is base. We do have frame 0 over here, frame 1 over here, frame 2 over here, frame 3 over here. Okay, there are two revolve joint. Okay. Okay, so that actually is kinematic diagram. Okay, so you have revolute joint. Okay, and also you have prismatic joint. Prismatic joint means you can actually do extension. Okay, in the lecture I do show you many more different type of joint. Not only these two. Okay, there are many more type. But in this course, we primarily working on the revolute joint and prismatic joint. Okay, so this one is that you can extend for longer. So to draw that, you just need to draw a box with one line. We know that this point is actually moving this way. Okay, a link, you use a line or a box is fine for me. Okay, so basically these are the basic symbol we will use. Okay, so and use that you can do 2D model or 3D model. So 2D model we based on this. 3D model you can draw a block link, you can draw a planary link, you can draw a prismatic joint, revolute joint in this way. Okay, sometimes we do draw this one. So this is 3D can show better than 2D is because this one can show you where it will extend, right? This one will show you where you will rotate, or maybe this way. You can put some symbol there to show people how it will rotate. Okay. Okay, so these are the 3D model. Okay, so for example, we do have a robot arm like this, right? And how we model it, how we can model it. So basically, this one, you do have a revolute joint over here, right? You do have another revolute joint over here, right? Two of them, and you do have a base over here, right? So let's see. It actually is that is you have a base, revolute joint, and then the planary link. Planary link is this one, okay, planary link. And then this is your model, okay? And then you need to mark the dimension for each one, okay? And then 2D, you have top view, side view, okay, different view. You can draw the view, but usually 3D, one 3D model is good enough, okay? But sometimes we may require you to draw the top view and the front view, okay? Okay, I think this one is from FRONT, not FRO. I think this one is FRONT, okay, not FROM. Okay, So this one is kinematic diagram, and then after you join the diagram, next one you need to assign the axis. You want to assign the axis, so you need to know where is your axis of rotation. So you need to show, okay, this one I want to be x0. So this one we have friend 0, you have x0, you have y0 and g0 over here. This one is a friend 0. Okay, a friend is a coordinate. Okay, and now that's actually the base is over here. Okay, and you can describe where this one is, and then now this one is your another location. Okay, so you right here you can also draw your SYG. Okay, you can also draw your SYG. That's assume that you do have SY. Okay. Okay. And then here, this one is frame 1, this one frame 2, this one frame 3. So your endpoint is over here. Okay, so basically you kind of need to use mathematical things to model this whole robot. Okay, so you provide the frame 0 information, frame 1 information, frame 2 information, frame 3 information, and then try to calculate it. Okay, but we just get started from the EG portion. Okay, so right here you kind of set up the coordinate. Okay, the assignment of the axis. But here there are some rule. Okay, there are some rule. We will talk about the rule. Okay, we'll talk about the rule in the picture. So there's a right-hand side rule. You always want to use the right-hand side rule. Okay, right-hand side rule is that if you took some physics course in high school or college or university physics course, you should learn the right-hand rule. Okay, right-hand rule. Right-hand rule usually happens when you have a cross product. Right? You have A vector cross product with B vector. You create a C vector. So your A vector is this direction. Your B vector, that's is actually this direction. Okay, and your C vector is this direction. And how to decide your direction is use your right-hand rule. So you will find a right-hand palm or finger, the forefinger pointing to this way. Your right-hand thumb is pointing to this way. So you cross over here. Okay, you cross over here, and then you will see. You cross your hand, you see that your thumb is in this location. Okay. Okay, so that's the right-hand rule. Okay, let me actually turn on my camera. Okay, turn on my camera. Actually, let me right here. Let me actually show myself. Okay, so I have a hand, right? I have a hand. So when this one is my right hand, maybe you cannot see it. Okay. You may not feel it. This one actually, because it's a mirror, this is my right hand. So my direction, actually my fingers direction, that's A direction. Okay. My fingers direction is A direction. My palm's direction, this one is your B direction. Okay. I'm sorry, let me sit back a little bit because you cannot see my whole palm. Okay, so this way going from that actually is let me use a pen or pencil. Okay. This is about a cross product. Okay. So I have my hand like this, and this direction that for the pen that actually is my A direction. My palm, this direction will be pointing. This direction is B direction. So you cross from A to B. Your thumb's direction is your C direction. Is that okay so far? Any question? So you have a hand, right hand. You have to use right hand. Your palm direction, this one is your A direction. You cross it to the B direction, and your thumb direction will be your C direction. Okay, that's the basic idea of the cross product. Okay, that's the basic idea of the cross product. So when we talk about a cross product, okay, this you have to use a right hand rule. So when we talk about right hand rule, you have to use your right hand to do it. Okay. So in the mass, x vector, okay, cross product is using cross y, okay, you become g, okay, g direction is the direction that you actually cross over to it. Okay, is that okay so far? Any question? Okay, this is the so-called right-hand rule. And right-hand rule is used to assign the axis. Okay, so same thing here. You can use this three-finger model, but usually I don't use this three-finger model. I use the finger direction, palm direction, and thumb direction. So A cross B, you get your CC is your thumb direction, is your product direction. Okay, so that's actually right hand rule. So these are basic ideas. So there are a few rules when you try to assign the axis to your coordinate. Okay, so there are some rules. Okay, the first rule is G axis must be the axis of the rotation or the direction of motion of the prismatic joint. Okay, so this one is a rule number one. Rule number one means just to tell you that, okay, when you have some 3D model, okay, when you have some 3D model, your G must be on the revolute joint, so this must be G. Okay, just don't think about X, Y now. Your G must be this direction because that's the direction that you do it. So now, after you assign G, then your X, Y, because you want to work on it using the so-called right-hand rule. So your XY can only be something like this, or your X is here, your Y had to be here. Otherwise, you cannot do cross product. You cannot do cross product. Okay, so that's a rule number one. You must determine the G first. Okay, G direction is where your joint would work, would take action. Okay, and if you are the extender of the prismatic joint, then your G direction have to be in this direction. It's the direction that you actually extend your rubber arm. Okay, any question? So that's the rule number one. Okay, that's actually the rule number one. Rule number one is G axis must be the axis of the rotation of a revolute joint or the direction of the motion of prismatic joint. Rule number two, X must be perpendicular to its G axis and the axis before it. Okay, this is rule number two. So let's go back here. Okay, it must be perpendicular to its own G and the G of the frame before it. Okay, let's actually look at what it means. So let's assume that your frame 0 is over here, your S0 is over here, and you're trying to determine the S1. You try to determine the S1. So your G1 is this direction, right? Your G1 is this direction, and then you say that your S1 need to be perpendicular to its own G and perpendicular to the G in the previous frame. So your S1 has to be this direction. Is that okay? Any question? This is rule number two. Okay. And why this rule was set up in that way? Just because that people figure out these are the better way to model the frames. Okay, that's the better way that you can model the frame. So that's a rule number two. The x-axis must be perpendicular to its own g-axis and the z-axis of the previous frame. Rule number three, all frames must follow the right-hand rule. Okay, this one cross-product rule, we already talked about it. Okay. Number four, each x-axis must intersect with the z-axis before it. Okay, so this one intersect. Okay, intersect rule. Rule number four is all every x-axis must intersect with z-axis of the previous one. So that is perpendicular and it has the intersect that actually is not hard to achieve because your x is this direction. So it actually intersect with the z before. So that actually is okay. You don't have problem. Okay, so that actually is fine. So these are the 4 rules you need to remember how to decide it. Okay, so this one, we do determine the z direction is here, z1 direction is here. Okay, these are the y. Okay, these are these are the x's, and you can determine the x0, y0. Okay, these are the so-called axes. Okay, after you determine the axis, okay, so these are the axes you want to determine. Okay, these are the so-called axes you want to determine. After you determine these different axes, next one you have to determine the a number. A number are the your so-called link length. Link length means that how much offset you got from the base of this rotor to here. This is A1. A2 is from this point to the second point. Okay, and then there's a A3. A3 is actually, if you have a rotor, it's actually in this way. How much is going out this way? That's actually A3. Okay, this one doesn't show it well. Okay, but there's a distance between your link and your body here. Okay, so this is the A3. A3 is over here. Okay, and your A4. So A number is your link distance. Okay, by doing this, you set up your basic model. Okay, you set up your basic model, and these also sometimes have some alpha. Alpha is your angle of your rotation versus your z direction. Okay, that actually is alpha. But this one, we will talk about it later when we need it. Okay, when we need it. So here, let's assume that we try to model this robot. Okay, again, this one we actually do have a revolute joint, and then we do have an extender. Okay, we do have this one. This is rotor. This one, and then there is an extender. There's an extender this way, going this way. Okay, so this one is the model we see right here. Okay. Okay, so this, I'm sorry, this last one actually, the endpoint is viewing the endpoint right here. So you see it's extended this way, so you can push it to make it longer. Okay, so that's that, and we can model like this. Okay, so first you determine your z direction. Your z direction is this direction. Your x0 is this direction, and your Z2, Z1 direction is over here. So you have an extender going this way. That's the displacement. There's a D number called displacement number. Okay. So that's kinematic diagram. So then you can extract the so-called data bit Hardenberg parameter. This is too much right now. Okay. This one actually is in later chapter. You would have to determine every joint's theta, and then A and D and alpha. Okay, don't talk about this right now. It's too far. That's too far. Okay, whatever. So these are the basic idea about a kinematic diagram. Okay. So for kinematic diagram, any questions so far? I try not to go into this David Hardenberg model. Okay, we will touch it later, but not right now. It's actually too hard right now. The only thing that you need to remember is how to draw the diagram. What are the 4 rules that you need to follow to determine your axis? Okay, that's it. That's about it. Okay, keep it simple. Any questions so far? Hi, Jay, are you okay? Hello? Abadip, any question?
I don't have a question right now.
Okay, no question, fine. I'm going to close this topic, okay? So then this the so-called kinematic diagram part, I'm done. Okay, let me go back to look at the weekly requirement for the homework. Okay, my purpose is discuss something you may need. Okay, so you do have a kinematic diagram. Then you kind of have the okay, you do have a kinematic diagram, and let's look at the programming assignment. Okay, I want to make sure that you don't have the problem. Okay, so you do need to look at the rotational metric. Okay, so we'll talk about a rotational metric modeling. Okay, so that's the rotational metric. So let's go back to the metric quotient. Okay, let's go back to the metric quotient. So here I'm going to, before we jump to the 3D very typical rotation or any other modeling, let's look at the simple modeling. Okay, simple modeling. So here, let's assume that, okay, first thing is that there's an original point. Here we have to have x1, right? Here you do have a object is located as xy location, okay? So how to find this mirror point, big X, big Y location, that actually is a mirror from the original point to here. How to find this point? If you are given this xy, the center point is actually 0, 0. How to get the coordinate of your xy? Okay, this one is called mirror. Okay, this one is called mirror. This one is also a transformation. The first transformation we talk about here is mirror. Okay, so mirror, we'll talk about a mirror. Okay, we'll talk about a mirror. And for mirror, how to you calculate this mirror location? It's not hard. Okay, so let's see. We do have one rule that you can understand that it actually, this one is the middle point of this P and the P bar. Okay, P bar P actually has a central point of this. Okay, so what we know is that okay, actually x plus x big X would be equals divided by 2 would be equal 0. Okay, y plus y big Y divided by 2 would be equal 0. Okay, so apparently you can solve the equation, and then big X is equals minus X, big Y is equals minus Y. So this is pretty simple. This one is minus X minus Y. You will have the middle point of this XY to here. Okay, so this one you're looking at is the so-called big X big Y method. Okay, big X big Y method. Okay, to find your transformation point. Okay, big X big Y method actually I kind of invented when I was in high school. Okay, so this one is a big X big Y method. Let's look at the second one. Let's assume that you have a XY point. Okay, XY point. You meter through this one called Y-axis. Okay, so this your P is over here, and they do have meter, and then to the other point here, this P bar. So what about this big X big Y here? Okay, apparently this one would be X would be 0, Y would be actually Y. Okay, Y would be Y. So you can solve the equation. Okay, you can solve the equation. You will see that actually your Y, apparently Y still Y. X will be minus X. So this one is your location of your mirror. If you mirror to the Y-axis. Okay, if you mirror to the X-axis, this point, you will have the same X and minus Y. Okay, that's your P double bar. Is that okay? So this one is when you do mirror. Okay, so we do sub 2, 3 different mirror way. Now next one, let's do have a translation. Okay, let's assume that right now I do have a point that actually is XY. Okay. Now I take a movement, drive a distance going this way by AB. what would be my X and Y here? Okay. So this one is pretty simple. If you have a vector like that, then actually you do have what? You do have X equals big X equal A plus A, X plus A, big Y equals Y plus B. So this is pretty simple, X plus A, Y plus B, okay? Okay, so this one actually is the movement. Okay, this one is the movement. But this one is pretty simple, but it's related to the next topic we are going to talk about. So this one, let me take a picture on it, okay? Take a picture on it. So this one is a simple movement, XY transformation, okay? So next one does assume that the object don't move. The object don't move. But here the frame move. The frame move by moving to a location. So this original point right here is 0, 0. You move to a new coordinate location is here. This one is called AB. Okay, so I do have a location. I do have an object here. Original is AB. But now, what is the address that I have according to the front one? What is the coordinate that I need to express in the so-called big X, big Y? Okay, so coordinate. So basically, your frame moved by AB is the same as your object moved by backward AB. So your big X, big Y will be X minus A and Y minus B. Is okay? Your object no motion, no move, but your observation move. Your observation point move to AB location. Then your coordinate original is black one. You look at the frame 0, your coordinate is actually x1, small x and small y. Now you move to a new frame, your observer move to AB location, and this time your coordinate of the same point with respect to frame 1, that actually is big X, big Y, it will become X minus A, Y minus B. Is that okay? Is that okay? So your object movement is the opposite of your what? Your object movement is your opposite of your frame movement. Okay? This actually is the motion. So basically, one is actually you do have a car. You are here. You're moving from here to here. So original acceleration is 0. Now it becomes A, right? But this is actually you move to the location A. But now if you originally your car is over here, right? But you don't move. The car don't move. But there's a photographer who originally watched it here is actually 0, but the photographer moved to here and take a picture. It becomes at the location minus A with respect to the photographer's new location. Is that okay? Okay, these are something you need to know. Okay, so translation is to change the coordinate. But if you have a frame change, it is the opposite of your object motion. Okay, that's what I want to say. And you need to remember that when you do transformation. Okay, that's the key point I'm trying to say here. Okay, next one. Okay, so this one is the translation. Okay, translation. Let's look at the rotation. Rotation will be a little bit harder to describe. Okay. So rotation means that right here, I do have a a point. It actually is located here called xy. And let's assume right here, this guy rotate with respect to the original point by an angle of theta. Now this new x, new y will be what? How can we calculate the big X, big Y in a very efficient way? Now this is the problem, right? That's actually it's a problem. So first things that's actually assuming that this guy is called phi. Okay, and the length of this one, let's assume this one is R. Okay, so this xy really will become R times cosine phi sine phi. Right? Any question? So x will be R cosine phi. Y will be R cosine phi. Okay? Any question? Any question? Then how to solve the location for big X and big Y. So big X and big Y will be R is the same. So blue R is the same as the red R. There's no problem, right? The angle right here, it will be very easy, right? So it actually, your big X will be equals to the red R times cosine theta plus phi and the sine theta plus phi. Right? I'm sorry. So your X is cosine times phi. Okay, and your sine, your Y, okay, your big Y will become R times sine theta plus phi. That's it. You finish your rotation. So you know your phi, you know your theta, you will be able to solve it, right? Phi is not hard to solve because you do have a xy. So your R is the square root of x squared plus y squared. Your phi would be R cosine of the x over R, right? Is that okay so far? Now you can get your phi, and your theta is given. That's the amount of the rotation you get. Okay. Any questions so far? Okay, so this one is to if your object move by an angle of theta, your new location is this is theta plus phi. So this is sine theta plus phi, cosine theta plus phi. We can further using a better, easier way to calculate it. Okay, and I'm going to tell you later. Okay, but at this moment, you just remember it's just adding the angle to your cosine and sine function. You finish the rotation. Okay, so first thing is that you need to know about the R, and you sub it. Okay, you sub it. Okay, so this one is like that. So now let's go back to another one that actually, how about your axis, your object no move. Your object is right here. It actually is xy. Okay, it's xy. Your object is xy. Okay, that's so this is still be theta. Okay, the length still be R. Now your friend actually here, your friend rotate by an angle of theta. Okay, so your friend 0 is a black one, is an angle of phi. So this coordinate, your xy would be, x would be R cosine phi, y would be R sine phi, right? But now your friend one, rotate by an angle of theta, right? Right? And then what is your big XPY now? So your big XPY is your new coordinate of the XY based on a new friend F1. That is here. There's an angle, this guy. This angle would be phi minus theta. Right? It will be phi minus theta. So basically you got what? You got your big X will be equals R cosine phi minus theta. Y would be R sine phi minus theta. So again, your friend option, your friend movement by theta is the opposite direction of your motion by theta. Your motion is moving, rotate by theta. Okay, the coordinate is the same as your friend rotate opposite direction by theta. Is that okay? Any question? Yeah, okay, must understand this, okay? Otherwise, you have time to understand how this different number goes. Okay, any questions so far? So these are basic idea you need to have, okay? I'm trying to talk about the basic idea of this translation. So far we covered the translation and rotation and the basic rule behind the so-called translation and and rotation. Okay, and whatever metric we will come up with will be supporting the calculation of these. Okay, will be supporting the calculation of this. Is that okay so far? Hello, is that okay so far? No? No question? Okay. So if no question, next one is we are talking about the calculation of, since we need require this a lot, okay, so you need to know about cosine theta plus phi and the sine theta plus phi. You would need to have that very important, okay? So one thing you must know about is the Euler formula and De Morgan theorem, okay? De Morgan theorem and Euler formula. So when we have a point, this one is called xy, okay? And you can represent it as r cosine theta, r sine theta, okay? You can also represent it as r theta if you are in a polar system, okay? If you are in a polar system, you can actually represent it in this way. But if you are in a complex system, if you are in a constant system, this one is actually x plus yi, okay, or iy, okay? And this one would be equal to r times e I theta, okay? Okay. And r we talk about it, theta we talk about it already. Okay, r would be equal to square root x squared plus y squared. Okay, theta would be equal cosine cosine x over r. Okay, these are the formula we will have. But remember, it is called r e I theta. Okay, so when we rotate to the new location, this one is okay. Here we do have a theta, and that's as soon as you rotate to phi. So this new point will be r times e I theta plus phi. Okay, that would be this one here. Okay, it rotates by a angle phi. Okay, it rotates by angle phi. Okay, let's actually continue to do this. Okay, continue to derive these equations. So you do have Okay, you do have R EI theta plus phi. Okay, this one would be equals to R times, okay, EI theta times EI phi. Okay, and this two thing actually is what? It will be equal to R cosine theta plus I sine theta times R, I'm sorry, no R, cosine phi plus I sine phi. Okay, so you actually try to extend it. You will get here the real portion. Okay, the real portion will be equal to the real part. The real part of it actually is this one times this one and this one times this one. Okay, it will be R. Inside here is cosine theta times sine phi minus, okay, sine theta times sine phi. Okay, and this one is equal to R cosine theta plus phi. Okay, let's actually try another one. You do have green one, and this one is actually the real part, the real part. The blue one is the real part, okay, real part. Imaginary part, you have an R, okay. Now this one, let me don't use the blue color, okay? This is no good. You get confused. So that's actually have the imaginary part. It is R. Now you do have this one times this one and this one times this one. Okay. So it actually would be Ri, but put I outside. Okay. Put I outside. It would be cosine theta sine phi plus, okay. Actually sine theta cosine phi. Okay, so this one very important. You do get the real part. Real part would be your new x. Image part would be your new y. That's it. That's why we look at. Okay, image part is your new y. New y is this one. Okay, let me take a picture now. Okay, let's take a picture. And let's actually erase it. Okay, so here we do have, let's actually look at here. Okay, so we do have an original point. This one is SY. It moved by an angle of the, let's assume this angle is phi. You rotate by a theta. You go to big X, big Y. You go to the new location. Okay, so here we already proved that your new X will be equal to the R times something, right? Your new Y will be also equals new R times something, okay? This is something actually is very easy. Actually cosine theta plus phi, okay? This something here is also sine theta plus phi. So you can actually look at trigonometry formula, okay? But here we kind of would actually just memorize and put it here, okay? So this one we do change it. It would be blue one. It actually is cosine theta cosine phi minus sine theta sine phi. Okay, and then here this one is sine theta cosine phi plus cosine theta sine phi. Okay, put this one. So we can summarize this one. Your xy vector will be equal some matrix times yours xy, okay, your xy. So we know your x will be cosine phi. Your y is equals to your sine phi. Okay, so this one is x cosine phi, and here you do have y. Y is r. R sine y is y. Okay, so here you do have, you can put cosine theta minus sine theta. Sine theta cosine theta. So you do matrix operation, this one, you get your x. Okay, and this bracket x is actually equal to r cosine phi. Y is actually r sine phi. Okay, and you time this one, you get this one. So that prove you the rotational metric. Any question? Hello? Any questions so far? I'm trying to prove how the rotational metric being calculated. Any questions so far? I do not follow the textbook, okay? So here I'm just trying to teach you how to come out with the rotational metric. Okay? And Nick, are you okay? Okay, no questions so far? Hopefully this one give you the basic idea, okay? Hopefully give you some basic idea of how to derive the metric rotation. But remember, this one is the motion of the object. This one is not rotation of the frame, okay? So the rotation of the frame actually is what? It's the opposite direction, okay? So this one will take a picture, and then next one, we are going to look at the, you actually call minus, okay, let's actually look at the other one, okay? So now let's do the opposite. So here we do have a object is over here. It actually is xy, okay. And let me plot it in a different location. Okay, that's actually do have xy. Okay, so points over here. Now, my friend rotate by a angle of phi. Okay, let's assume that this one rotate by phi. Okay. And your original data here, okay, let me be consistent. Let me call this one theta. Okay, let me call the sy as, let me call the sy s equals r cosine phi, y equals r sine phi. Okay, let me call it this way. Okay. So now your object no move. Your coordinate move by an angle of theta. Your original angle is phi. So your end result, this new coordinate with respect to frame one, your body no move, your frame move. Your frame move. Okay, your body no move, your frame move. Your object move by theta, but now if your frame move by theta equal to your object move by minus theta. Okay, so with that we can derive your xy, okay, equal to, I'm sorry, big X, big Y, okay, big X, big Y location. So big X, big Y location with respect to a metric to the original one. So this one actually is equals minus theta, right? Your angle actually rotate, your frame rotate by theta, right? Your frame rotate by theta. And in fact, it's the same as your object rotate by minus theta. So cosine minus theta would be equal to cosine theta because it's actually a even function, okay? And sine minus theta will be equal to sine minus sine theta. It is an R function. So here you do have cosine theta, sine theta, minus sine theta, cosine theta. You get this, right? You get this. Does that make sense? Does that make sense? So this one is your new coordinate based on the new frame. Okay, so your new coordinate based on your new frame. This one we can actually do. Okay, it's a rotational metric. Okay, rotational metric from actually the new the range for 0 with respect to frame 1. Okay, your new location is like this. Okay, okay, like this. Okay, now let's do the opposite operation. Let's do the opposite operation. Okay, the opposite operation is. The opposite operation is, let's actually go back. Let's do opposite operation. So right here, how about this? How about if I do have here, if I do have big X, big Y, how can I solve my XY? I will need a metric. This one is my rotational metric of the frame 1 with respect to my frame 0. Okay, this one is minus theta. So here again, it rotates back. So it is using theta. So this one again is go back to cosine theta, sine theta, minus sine theta, sine theta, cosine theta. So your older coordinate, if you do know the new coordinate, and you try to calculate, if you have the pin one, you try to calculate your original one, then the metric you use is the same as your object motion by theta. Is that okay? Happily enough, that's simpler. Any questions so far? Okay, these are not too easy, okay? So you have to understand it. Any questions so far? Okay, so this is 2D, but remember these different metric formation and calculation, okay? So basically, why this one is very important, because sometimes you do have the number that you observe from the new frame. Say you do know you have a car, that car is driving. You do know where you are with respect to the car, but you do not know your absolute location with respect to some building. So in that case, you use your coordinate with respect to the car to calculate your absolute location with respect to a certain fixed point location. Is that okay? This one is more openly used than this one, than the lower one. Any question? Hello? Is that okay? So let's actually go back to the first talk we talked about. We do have a robot. There are some rotor, okay, whatever. Here we have a frame. As soon as this is frame 3, this one is frame 2, here frame 1, and we do have a base frame 0. Okay, so I do know there's an object. It's XYZ with respect to the frame 3. Right? So basically I have this XYZ. Okay, so I want to calculate this coordinate based on frame 2. So there's a frame 2 XYZ you need to know. And that one is your rotational metric observation from this one. Okay, your frame 3 is rotation based on frame 2. You can recover and you can know about what is the location with respect to frame 2. And this thing you know, then you can actually add another one called the rotational metric 2 versus 1, and then you will get another one SYG that's actually with respect to frame 1. So you will know about this location based on frame 1. So then you can continue to calculate using rotational metric 0, and then you get the final XYG based on the base point. Right. So your base point location will be equals R rotational metric of the frame 1 versus frame 2 times frame 2 versus frame 1 times frame 3 versus frame 2 times the coordinate that you observe on the frame 3. Okay, this is a combo rotational metric. You can write it in this way. Okay, I'm trying to use a simple concept to teach you. I don't want to go into those very complicated detailed math. This is the way that I can try my best to tell about it, talk about it. Okay. Any questions so far? And then other than this, you have to work on the homework. Okay, to figure out how to calculate the different value based on using your Python. Okay. Any question? Okay, if no question, I propose to end the talk today here, okay? Because my purpose is to have this discussion to discuss some homework if you don't know how to do it, okay? But here I try not to give you too much extra workload because there are tons of video you can watch, okay? So, but my purpose is not to add more video into it, okay? I don't want to repeat whatever we already covered in the lectures, okay, in the lectures. So my purpose is trying my best to give you the idea of how this different number and metric being created, okay? And then you know how to use that. Any questions so far? Any question?
I don't have a question.
No? How about you? Any question? No? Okay, if no, can we stop here?
No questions.
Okay, so that's it for today, okay? Thank you. And next time you have question, you're welcome to post, okay? You can post me some message or you can actually in the class ask me, okay, in the Tuesday, Friday session, trying to give me the question. I'll try my best to talk about it, okay? But I try not to go back to talk about whatever I already put in the video because what? I will add many more video for you to watch and that makes no sense, right? That makes no sense. My key point for having this discussion part is to give you the simple idea of how things are handled, okay? And don't want to add extra burden on you, okay? If no question, that's it for today, okay? Thank you for coming and see you on Friday, okay? Bye-bye. Bye-bye.